Hello everyone. So in the previous video, we looked into an application of differential equation in a tank mixing problem. So in this video, we'll also look into similar problem, but slightly different than the previous problem. So this is application part 2. So let us draw a tank. So I'm not writing the problem. So I'm just expressing the problem in a diagrammatic manner. So suppose you have a tank where pure water is flowing into at a rate of 10 liter per minute, and the content is thoroughly mixed as the previous problem, and the content also flows out at the same rate, 10 liter per minute. But here is a slight change, that a salt is added to the tank at the rate of 0.1 kg per. So here salt is added. Now let us write the initial conditions. Initial, the tank has 100 liter of water with 10 kg of salt. So you have to find, the question is to find the amount of salt in the tank after 30 minutes. So how much salt is in the tank after 30 minutes. So we set up a differential equation according to this problem. So let St denote the amount of salt at time. So ds dt denotes the rate of change. So this is rate in minus rate. So rate in we know that is 0.1. So it's 0.1 minus rate out, that is the concentration into the flow, that is 0.1 minus S by 10. So you can write it also as 0.1 minus 0.1 S times S. So the differential equation becomes ds dt equal to 0.1 1 minus S with initial condition S0 as 10, because we started with 10 kg of salts. So this is a separable differential equation. To bring that part down, 1 minus S part down, equal to 0.1 dt, integrating both sides, integration ds by 1 minus S, integration 0.1 dt, minus log 1 minus S equal to 0.1 t plus c. So from here we get st equal to 1 plus c. This is just few steps, you can check the steps. Okay, now using initial condition S0 equal to 10 implies 10 equal to 1 plus c. So c equal to 9. Hence S of t equal to 1 plus 9 e to the power minus 0.1 t. This is the amount of salt at any time t. Amount of salt at time t. But we have to find S of 30, right? That is the amount of salt after 30 minutes. Amount of salt in the tank after 30 minutes is nothing but S of 30 is equal to 1 plus 9 e to the power minus 30 into 0.1 is 3, right? You can check, this is 1.448 kg. So this example is done. So let us quickly go through. So what change we had in the previous one, in the previous example, we did not have this component. Rating was 0 because only pure water was coming in. But in this case, we had some positive uh, thing because salt was also introduced. So let us, but one thing you check, note that here the flow of water, mixed water, what is coming inside and what is going out, both are same. Now let us check what happens if the rates are different. So it's another problem. So I start with the usual one, that is, we have a tank. We have a tank. Suppose the water is flowing in, pure water, at 12 liter per minute, and water is flowed out 10 liter per minute. So here the rate is different. So here I'm not taking into consideration that salt is also put into the water. That we will see later. Initial condition 100 liter with 10 kg of salt. So here you have to note that these two quantities, this and this, this and this are different. Okay, so one can easily check that since on 12 liter of water is going inside and 10 liters of water is going outside, mixed water. So volume, suppose we denote by Vt, of the tank is increasing, right? So it is 100 plus 2t, because at every minute 2 liter of water is staying inside the tank, it is not getting outside. So volume of the water, volume of water after 30 minutes. So since the volume has changed, so the concentration of the salt will also change after 30 minutes. So concentration is what? The quantity by volume. So volume is now 100 plus 2t. Rate of change ds dt equal to minus rate in minus rate out. But since we are not adding any salt, which is 0, since no salt is added. But this thing we know, the concentration times the flow. So our differential equation turns out to be dsdt minus 100s, sorry, 10s by 100 plus 2t with initial condition same, s of 0 equal to 10. So this is our current differential equation. So this is also separable. So what we get from here, ds by 10s, okay, we can keep the 10 that side only, not to matter, minus 10 by 2t dt. Now integrating both sides, integration of ds by s equal to integration of minus 10 by 100 plus 2t dt. So this everybody knows, this is log of mod x minus 5 ln of 100 plus 2t plus c. So simplifying we get is equals to c 100 plus 2t to the power minus 5. Let us write s of t here. This we got the amount of salt in the tank after 10 minutes. Now using the initial condition s of 0 equal to 10, we have 10 equal to c, 100 to the power minus 5. So implies c equal to 10 to the power, and here in this side it will be 10 to the power 10, this will go here, so it is 10 to the power 11. So thus s of t equal to 10 to the power 11 times 100 plus 2t to the power minus 5. So after 30 minutes, the amount of salt in the tank is s of 30, 10 to the power 11, 30 into 2, 60, right? 160 to the power 5. Also approximately, you can check, 0.95367 kg. Just quickly recap. So this was the case where the rate in was different than the rate out, the flow. So hence we had a change in the differential equation. Our volume changed due to time. That's our concentration rate changed, and hence our differential equation also changed. Otherwise, the remaining steps are similar. Okay, hope you enjoyed the video. So let's